Okay, this is part 2 of the Algebra 2 second semester review. Picking up at number 16, we have y to the 3/5 is equal to 8. So that would be rewritten as the 5th root of y to the 3rd is equal to 8. So to get rid of the root, you're going to raise both sides to the 5th. And that's going to give you y to the 3rd is equal to, go to your home screen, 8 rooftop 5. And 32,768. 32,768. You need to find the cube root of that. So math 4 and 32,768 is 32. So your answer here is y equals 32. Looking at number 17, 1 over 25 would be the same thing as you could turn that into a decimal. You could also realize that that was 5 to the negative 3. You might not want to do any of those. Probably 1 over 125 is equal to the 5th root of x to the 3rd. Because I think that said x to the 3/5. Yes, it did. So you're going to raise it to the 5th. So you're going to want to say open 1 divided by 125, close rooftop 5. We're raising it to the 5th because we're getting rid of the root over there. And you get a really small number, and then you're going to rooftop that to the open 1 divided by 3 to get rid of the cubed. And you get 3.2 times 10 to the negative 4th. 3.2 times 10 to the negative 4th. Okay, moving down, changing topics now. When you look at number 18, 9 times 1/3 to the x. A is the number at the front, so it's 9 on this one. B is the number that's the base, so it is 1/3. Your domain for exponential is always ARN. Growth or decay, this is decay because B is a fraction. If you put this in your calculator, you get an idea that your graph looks something like this. Moving to number 19, log base x of 64 equals 2. This becomes x squared is equal to 64. Square root of 64 is 8. Number 20, subtraction becomes a fraction, so log base 5 of x over 2 is equal to 3. If you only have log written on one side, you have to rewrite it in exponential. This becomes 5 to the 3rd is equal to x over 2. 5 to the 3rd is 125 is equal to x over 2. Take your 2 over and multiply it, and so 250 is equal to x. Looking at 21, addition becomes multiplication. So this becomes log base 2 of x plus 3 times 16 is equal to 7. Once again, you only have log on one side, so you're going to have to rewrite it in exponential. So it becomes 2 to the 7th is equal to x plus 3 times 16. If you want to go ahead and distribute that, you're going to get 16x plus 48. 2 to the 7th is 128 is equal to 16x plus 48. You can solve by hand. You can put it in y1 and y2, whatever you want to do. I'm going to solve it by hand. When I subtract 48, I get 80 is equal to 16x, and I divide by 16, and I get 5 is equal to x. Okay, going to the next page. Looking at 22. When you solve using long division, it's like when you were in elementary, and so we're going to say x squared plus 4x plus 3 on the inside, and we're going to say x plus 1 on the outside. Remember that if you have any skips in exponents, that you need to put in a placeholder with a 0, okay? So what would you multiply x by to get x squared? Well, you would multiply it by x. And so x times x is x squared plus x times 1 is 1x. You're going to draw your line. You're going to change your signs and combine. So 4x minus x gives you 3x, and the x squareds cancel. So now bring down your plus 3. What would you multiply x by to get 3x? a positive 3, so you're going to say plus 3. 3 times x is 3x, plus 3 times 1 is 3. Draw your line, change your signs, everything cancels, and so there's no remainder, and so your answer is simply x plus 3. 23 is still division, but it is synthetic. So with synthetic, you're going to put the number with the opposite sign, so a positive 4 on the outside. Then you're going to put your coefficients. Don't forget you have to do placeholders. If it skips, this one does. We have 1 for x to the third. We have 0 for x squared, 0 for x, and negative 64. Draw a line. Bring your 1 down. 4 times 1 is 4. 0 and 4 is 4. 4 times 4 is 16. 0 and 16 is 16. 4 times 16 is 64. Negative 64 and 64 is 0. The 0 here means there is no remainder. Since my problem started with x to the third, my answer will start with x squared. So that becomes 1x squared plus 4x plus 16. And that is my answer. All right, 24 wants you to solve x to the fourth minus 6x squared plus 9. You're going to start by saying that a is equal to x squared. So it becomes a squared minus 6a plus 9. X squared got changed to a, and then a squared for x to the fourth. So then you could factor it. You could put it in y equal and look at your graph or your table. You could use a quadratic formula. You could, I think I already said factor it. There's so many different ways. I'm going to factor it. I'm going to find the factors of 9. 1 and 9, 3 and 3. Signs are the same, and they're all negative. And they have to equal negative 6. So it's negative 3 and negative 3. So you have a minus 3 and a minus 3. So you take each of those, and you set it equal to 0. And you move your 3, and so you get a equal 3, and you get a equal 3. So then you have to go back up here and say, well, then 3 is equal to x squared. You have to unsquare it. So plus or minus the square root of 3 is equal to x. That's all there is to your answer on this one, because both of my a's came out to be the same thing. If you had had a equal 3 and a equal 5, you would do this last step twice. So looking at number 25, you got to give the domain, the range, the x-intercept, and the y-intercept for the following. Your domain, your range, your x-intercept, and your y-intercept. So we're going to start by going to y equal, clear everything out, and put our problem in. So we have x to the third plus 9 divided by 4. Take a quick look at your graph. So I'm just going to go zoom 6. And you can tell that it is continuing on. Your domain and your range are both going to be ARN. To find your x-intercept, you got to go look where y is 0, and to find where your y-intercept, you got to see where x is 0. So let's actually tell this to start at 0 and go back. And if x is 0, y is 2.25. So your y-intercept is 2.25. Looking, going up on your table, let's see if we never get to 0. So you're going to have to do, go to y equal, put a 0 at y2, and you're going to go second, calc 5, let it draw, enter, 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 and x is going to be negative 1.3, negative 1.3. So 26 is going to work the same. So we're going to start by going to y equal. We're going to clear that out, and we're going to say x to the third minus 3.25. We're going to take a glance at our graph, and we're going to discover that sure enough, domain is ARN and range is ARN. We got to figure out the x and the y-intercept still. So we're going to go to our table, so second graph. If x is 0, y is negative 3.25. So your y-intercept is negative 3.25. To find your x-intercept, you're going to have to go second, calc 5, let it draw, enter, 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 and we have 1.48. Okay, so we're ready to go to the next page. Looking at number 27, list the transformations to the parent function. Remember, if it is trapped in parentheses or under a root, it is horizontal and it does the opposite of what you would expect. Anything else is a vertical change. So I have a negative that's trapped inside, so it is a flip and it's over the y because that's the opposite of what you would expect. 3/2, that is larger than 1. It is a horizontal change. Since it's larger than 1, you would expect it to be an expansion, so that means it's actually going to be a compression. Those are the only two things causing changes. This right here is a typo, so ignore that point. We have minus 2.75 trapped inside, so it's horizontal. It does the opposite, so it goes to the right 2.75. Number 29, we have a negative at the very beginning, so that is going to be a flip over x. We have a 1/2 at the beginning, so that's vertical. It's smaller than 1, so it's compression. Number 30, everything is trapped inside, so it's horizontal. So we have a negative. That's going to flip it over y. We have a 0.25, which is smaller than 1, so you would think compression. It's actually going to be a horizontal expansion or stretch. Number 30 wants you to solve it. You're going to start by moving your 13 to the other side. So we have the cubed root of 4x minus 12 is equal to 13. We're going to cube both sides, and so it becomes 4x minus 12 is equal to 13 to the third. So if we come over here to the calculator and we go to the home screen, we say 13 rooftop 3, we get 2197. We're going to add 12, and so 4x is equal to 2197 plus 12, which is 2209. Last step, we're going to divide by 4. And so we end up with 552.25. 552.25 is what x equals. 32 wants you to analyze the minimum and maximum values over the given interval. So you're going to start by going to y equal, clear it out, and put your equation in at y1. So we have math 4 to pull up the cubed root of x plus 3. Make sure all that's under this cubed root. Go second graph to pull up your table, and at -4 we have -1, and at 5 we have 2. So our minimum is -1 and our max is 2. Okay, going to the next page. I'm actually thinking that this is probably well, we'll do one more problem. Find the inverse. The first thing you do is you change this to a y. Then you swap your x and your y. So x is equal to 1/2 times y plus 2 to the third. You're going to come over here, and when you divide it by 1/2, you actually multiply by 2. So 2x is equal to y plus 2 to the third. You got to uncube it. So we're going to say the cubed root of 2x is equal to y plus 2. Then you got to move that 2. So the cubed root of 2x, make sure the -2 is obviously not under the root, is equal to y, which you're actually going to change to f -1 of x. That's your answer. Okay, I'm going to stop this video here because I only have about a minute left and we have several problems. There will be another video that finishes up the review.